Hello everyone. In this video I'm going to be doing a controller swap on a laser cutter I picked up on Craigslist. I already had a laser cutter that you might have seen in some previous videos. It's one of those K40, supposedly 40-watt laser cutters that you can get on eBay for like $500 or so. It's been a good laser and it's treated me pretty good, but it's a little bit small and a little bit underpowered, and with the opportunity to get this much bigger one, I decided to go for it. The only problem with this new one is it uses this as the controller. This is a Pentium 1 computer with about 500 megabytes of RAM, and it has a PCI card inside that is the motion controller for the laser. If this thing ever dies, or if it slows down to a crawl, which it pretty much is, the laser is nearly useless. Right now it works okay. It does take about 15 minutes to boot up into Windows XP, but other than that, it does work. But I want to switch over to something a little bit more modern, so I'm going to be swapping in this guy. This is an AWC708C Lite that you can get directly from China. A lot of new laser cutters are coming with this. I think lightobject.com has this rebranded as the X7. This is a DSP controller, a lot more powerful, a lot more modern. Has this nice big LCD display that shows the current tool path and the file you're working on. Has a USB jack right here in the front, Ethernet, all that good stuff. So the benefit that this gives me is I can actually run this with or without a computer. I can take a thumb drive, plug it directly into here and just load it just like that. I can also operate this over my network, so I can be inside, send a file to it, then boot up the laser and just hit go. And as far as motion control, it should be smoother, faster, better, all that other good stuff, and just generally give me more control. So I'm going to do a little bit of a teardown of the laser first, just to show you what all is inside of it, how all the pieces work, and then I'm going to be taking out this whole system and replacing it with this. Behind me here is the laser cutter that I will be converting. I picked this up on Craigslist for $300 and included a whole bunch of accessories, so it was a screaming deal. This is a Bright Star laser, that's the brand. It's really just a rebranded Chinese laser. There's a lot of different companies that make pretty much the same exact thing, so it might look familiar to you. We've got the doors that open down here. We've got the nice lid with the hydraulics on it. And when I bought this, the guy said it was a 30-watt laser, but there's no way. If we look over here, we can see the little cover on the side. That's all laser tube. The laser tube goes all the way from there to there, about 48 inches in length. If you know anything about CO2 lasers, you'll know that the length of the tube effectively dictates or is a good indicator of the power of the laser. That's why I'm pointing over here because that's where my other laser is. That's why the K40 laser is the 40 watts, and the reason I'm putting this in quotes, that's why they're really only spec'd about 25 watts, because for that to be a full 40 watts, the tube would need to be like 6 or 10 inches longer to actually get that kind of wattage out of a CO2 laser. This one, however, if you look at the size and the specs for a typical 60-watt laser, it's usually about 48 inches long, and all these specs and size matches up with a 60 watt. And based on some preliminary cuts, I would definitely say this is a full 60 watt. I could go online and buy like a laser meter, but I'm not really going to spend $500 or $1,000 just to prove that this is 60 watts. I'm just going to trust that it's 60 watts. The power supply is made for 60 watts, so I'm just going to assume that it's 60 watts going on. So I'm going to kind of show you a couple little things about this laser, and then we'll swing over to the back and I'll show you the current control mechanism, just so everyone gets an idea of this. I'm sure there's someone else out there that's looking to put one of these controllers into their laser. I looked on YouTube and couldn't find that many videos of where people had done this or really documented the process, so hopefully this video serves as documentation for someone that's looking to do it in the future. Up here we've got the e-stop, and this is basically the main power for the unit. There is no other power switch really. This controls it. There's also a key lockout. I might keep that, I might disable it. It's kind of redundant to have both of these, especially in this kind of environment where I'm the only one using it. The computer also has a USB dongle that if the dongle isn't present, it doesn't work. So there's a lot of control lockouts to this, which are kind of annoying because if you lose the dongle, the whole thing's dead and doesn't work. And over here is just the basic control panel. It basically sends commands back to the computer, and then the computer actually does the controls. And it's basically start, stop, pause. You've got an up, down, left, right for jogging the laser. You've got the power meter for the laser itself, and this is very important, and I will be keeping this. I'm going to put this like right down below the controller. It's very important to know the power output of the laser. If you go much beyond 20 milliamps on the laser, you're going to degrade the life of it. So when I'm setting up this controller, I'm going to be using this analog display to calibrate the max power setting so that I'm not going significantly beyond 20 milliamps. I want to be somewhere around 18 or 19 as the max, because anything else is going to shorten the length of life of the CO2 laser tube. And then you also have a couple other little things like reset, test, just does kind of a quick test fire of the laser, and an edge, which is actually kind of a cool feature for this. It'll basically look at the bounding box of whatever it is you're cutting, and it'll just kind of do a little box, jog the axes around the box just to show you, where you are centered. And all of these features are going to be in the new controller, so I don't really worry about this. The new controller is going to be just kind of centered around here. I'm going to build a box that goes on the outside. So I'll maintain all of this functionality with the new controller, but this control panel will effectively go away. The other thing I like about this laser is that it has this nice big open area down below, and with these belts and pulleys, it actually has a movable Z-axis. Now the Z-axis is not motorized yet, but hopefully in a future video I'm going to motorize it, because this controller actually has the options to do autofocus and even jog the Z-axis up and down. Focusing is not entirely important on a laser. It is important to focus the laser, but you don't have to be perfectly precise like you would on the CNC mill. You basically need to get it to where the beam focus is somewhere either on the top of what you're engraving or somewhere in the middle of what you're cutting, and there's a pretty wide variance depending on the lens you have and everything. So this isn't super critical, but it does have a little hand crank up here to where I can move the Z-axis stage up and down, and that's nice because my other one doesn't have that. And so if I have something really tall, I'm just kind of out of luck. I can't really move that. So that's nice. So let's kind of slide around to the back, and I'll show you kind of the guts on the back of the unit. Here is the back of the machine. I've removed a couple of the access panels just to give you a better look inside. At the top, you can of course see the laser tube. It extends maybe another foot or so that way. I just took off, cropped the shot in a little bit just so you could see more of the insides. And here you can see the water cooling lines. These are the lines that go down to the pump and the chiller and runs water through the tube to keep it cool. And then if we focus down here, you can see there's all the electronics are down here. Starting from this side, there's a 36-volt power supply. This is going to be what drives the steppers. You've got the stepper drivers, one right here and one right there. So that's your X and the Y, or probably Y and X, whatever. And then over here is the breakout board for the actual motion controller. You can see this big cable that runs over there and then actually out over to the computer that I've got over here behind me. And this is basically just a breakout board. You can kind of see it connects out to all the various bits and bobs on the controller, and it's nice and labeled so that you can see it goes over to the X-axis, over to the Y-axis, and then over to the power supplies, things like that. So that will be the core of what I'm going to be using. And over here you can see a couple different power supplies. Now this was really confusing because we have a 36 and then we have these two guys which aren't labeled. And it took me a while to kind of probe all these and figure out what was going on, because this one is actually connected into the breakout board into the +24 and ground. And that's really fortunate because the controller I'm using is 24 volts for the power supply. So I was thinking, awesome, I'll use one of these. But then when I put the meter on it, I found that it's only 5 volts. It turns out this is 5 volts and it's going into the 24 volts into the breakout. I don't know how that's working, but I guess it is. However, these are both dual voltage power supplies, meaning they have a 5 and a 24 volt output. What's strange is this one's connected to the 5 volt out. This one's also connected to 5 volt output. This is actually powering the little laser pointer that's on the gantry. but both of these are basically just a 5 volt in this application, so that's kind of strange. But when it comes down to it, both of these will output 5 and 24 volts, so I can use the 5 volts for the laser pointer or other little accessories on it, and then the 24 volts I can use to power my new controller, so that's good. I'll just end up only using one of these. And then there's a little EMI RF filter up here just to filter the AC noise coming in. And then over here is the power supply for the laser. It's mounted a little precariously right there, but it seems to be working, so I'll most likely keep that where it is. But this is generally what the back looks like. I took some of these things apart and probed them just to figure out where all the wires go, and I have a pretty good idea of what all the wires are. So really it's just a matter of disconnecting this breakout board, connecting that into the new controller, inputting some settings, and then testing it out. So I'm going to start with the settings first, and then I'm going to do the wiring last. I lucked out a little bit. I did some digging in the laser cut software that the old controller comes with, and under the options and machine settings, I found most of the settings I need. This is like the pulse unit, which is how many pulses it takes to move a set unit 1 millimeter or whatever, and that would be kind of a pain to calculate because then I have to look at the controllers, figure out the micro stepping, and then look at the belts. And so that's nice that this is already set up for me. It has the range of the table, so I don't really have to go and measure that. And then some other speed parameters and stuff. So I can copy most of these settings and just dump them directly into the new controller. There's a lot of motion specific settings in a new controller, like acceleration values and things like that. I'm going to leave those pretty much as the defaults, but this is the stuff that I was really worried about because I didn't want to sit back and have to calculate all of this. So I'm going to take these settings, copy them down in my notebook, and then put them into the new controller. I'm going to do that off camera because it's really not that interesting. They have a little Windows program that you can actually download, and you can put all of that into the program and then just send it over to the controller, so it makes it real easy. You don't have to sit there with the up, down, left, right and input all these parameters. So I'm just going to do that directly through that program, save it directly to the controller, and then hook it up to the motors and see what happens. Before I install all of this into the laser, I wanted to show you everything that comes with this kit. I got this just from some random seller on eBay. You can get it from any number of different places. I paid about $350 with shipping. You can pay a little bit more or a little bit less depending on where you find this, but the AWC708C is pretty generic and you can find it in a lot of different places. First up, it comes with the main control panel that has the LCD on it. And this piece has a couple connections on it. It has two right here that connect back to this brain unit, and it has one here on the side that goes to this little breakout, and then you also have a USB on the back, and then a USB on the front as well. This little breakout right here is this cable, which it comes with, and it's a pretty good sized cable, and this allows you to connect an RJ45 and a USB remotely. So you can put this somewhere on the side of the machine, on the back of the machine, or wherever you want to remotely locate your Ethernet and USB, and then that just connects into this control panel. So that's kind of cool. The main brain unit is this, and it has all these nice like Phoenix terminals everywhere on the outside of it, so it makes connecting a breeze, or I hope it will. And you've got the X, the Y, the Z. It also supports a U-axis or rotary axis. 24 volts in, pretty cool. Limit switches. It has some generic inputs and outputs for like controlling a laser pointer. There's like a foot pedal switch that you can configure if you want to have more safety lockouts, like the lid being open, or a foot switch, or a chiller being on. So it has a lot of really cool ins and outs that go on this. And it's kind of a neat form factor, and I like all the Phoenix connectors, so that comes with it. And these are the two connectors that connect back to that, and these are the cables that connect to that, and you can see they're actually really long. These come with it as well, pre-terminated, so that's really nice. And this will allow you to locate these pretty much anywhere inside the case. So I have the option of having this on the front, and this can go pretty much anywhere inside the case that I want, so that's cool. In addition to that, it also comes with a really long USB cable, which is nice, and then also a very long Ethernet cable. So it's really cool that they include pretty much everything you need other than the laser cutter to put it into. This did not come with a manual, as you see, as is tradition for Chinese electronics. However, a little bit of searching on Google led me to a PDF of not only the LaserCAD software, a firmware update for this, and also a wiring diagram, as well as the full manual for this and for the LaserCAD software and all the drivers. It was actually really easy to find, and I can put some links down in the description for this video, but with the manual for both this and the hookup for that, it's really easy. So I'm not going to go into the configuration and how to use the software at all in this video, because actually the manual is very good. So I just want to show the hookup, which was a little bit lacking in the manual and documentation. But as far as using the software and using the controller, check out the links in the description. They're very good at detailing all of that. So the next step is to actually just wire this up into the machine and get it moving. Before I just started ripping things out and putting in the new controller, I wanted to kind of document how everything was hooked up in the existing laser. So I grabbed my phone and I just started taking a lot of pictures and writing some notes down in my notebook, just so if I ran into an issue, I could see how it was originally hooked up, and then I could reference the notes and maybe figure it out from there. I ended up not needing this as everything was pretty straightforward, but it's always a good idea to take pictures and write notes before you start gutting something. I printed out the connection diagram that I found online, and I just kind of started with each connection and testing out and went from there. So I started out, I think, with the X-axis. I just connected up that stepper driver, tested that out to see if I could get everything to move. Then I hooked up like the limit switch for that, then went over to the Y-axis, then its limit, and I just kind of, stepped through all the connections like that, finally ending up with the laser power supply. The laser power supply was, slightly tricky, but following the diagram, it was perfectly fine. There's just this unused pin that was connected on my power supply and the original controller that ended up not being connected on the final controller. There's something to note about the laser power supply. When I was looking through all the wiring and everything on the machine, I noticed that the controller board actually didn't have anything to do with the additional safety lockouts of the machine. On the front of the machine, there's the e-stop, and then there's also the key switch. But in addition to that, there's a switch or a connection that goes down to the chiller, and also a magnetic switch on the lid of the machine. And if the chiller isn't on or if the lid is open, the laser won't fire. And that actually has nothing to do with the controller. I realized that they were connected back to the laser power supply, and it was connected onto one of the pins. And from the wiring diagram of the new controller, they show these two pins jumpered, and essentially that's what those switches are doing. Those switches are jumpering between those pins and allowing the laser to fire. So instead of relying on the controller for these lockout mechanisms, I just kept the original wiring set up for the power supply, so if the lid was opened or if the chiller wasn't on, it would actually not jumper those two pins and the laser wouldn't fire. So I just kept it like that. It's a nice simple mechanical way of making sure that everything runs smoothly. Once I verified everything was working as it should, I decided to gut all the old electronics and take out all the wiring. This really wasn't that bad. I just had a ton of zip ties I had to cut out. The control panel on the front was a little tricky just because of how it was located, but once I got all the nuts undone from the back side, the whole control panel just kind of came out, and it left me with this nice hole that I will use to route the cables for the new control panel through. Since the back of the laser was relatively crowded and I kind of liked how everything was already laid out, I decided to use the inside side wall of the Z-axis compartment, let's say, to place the controller. I just used Velcro because really this doesn't need to be bolted down to anything. It's not going to have any stresses on it, and it really fit well up against the side wall of the enclosure. And I just kind of routed all the wires back to it using the existing wire channel. So here's what everything looks like with the new controller installed. I just have the leads coming out through the control panel hole, and eventually I'm going to need to make some sort of box or enclosure to fit this control panel right here. But for right now, you know, it's connected and everything works just fine, as you can see. So it's good. Everything moves around just fine. And you can select your files and do everything from here. So it's really nice. I don't have to use a computer for this, and I still have the analog current meter for the laser hooked up. So that I need to, you know, mount somewhere else. I might integrate it with this control panel or not. I'm not 100% sure, but I really, really like this, and this is a huge step up from the original controller. The main reason for doing this video was to give everyone a little bit better idea of what's involved in swapping the controller on one of these lasers. Having now gone through this process, I can say that it is very easy. If you're looking to do this, don't hesitate 1 second. Not only is the laser controller infinitely better, the laser just operates so much better and it's so much easier to use. But really the installation was cake. Once I printed out the wiring diagram and figured out, you know, kind of what the wiring was already on the machine, it was really just a matter of terminating the wires. And I hate doing wiring, so that was kind of the biggest holdup to doing this project. Is I really hate just, you know, wiring everything up. But once I got past that, it was really easy to hook up. Everything was very straightforward. And in recommending something like this versus a smoothie board, or, you know, something similar like that, I would highly recommend going this route because there's just no real configuration. Everything's pretty much pre-configured for a CO2 laser from China. So really I just had to change, I think, maybe 2 parameters in the software, and that's it. Everything else just already was set up, and the control panel is already laid out for a CO2 laser, and everything just immediately fell into place. So I would highly recommend going this route other than some other control scheme. It is a little bit more expensive, but I think it's well worth it given the fact that it connects to Ethernet, you have the thumb drive in front, and just the form factor and the ease of use. So I really like this controller, and I'm gonna really enjoy using the laser now. So stay tuned for more new videos, and thanks for watching.